Okay, so I'm going to just do, I guess I'll do one example and then you'll do one example. Um, so here's the circuit that we're going to solve. I don't think we've done this one, have we? 140. I don't think so. We did this one. Okay. Let's do a different one. I have plenty of examples. Don't worry. Okay, how about this? Since you think you're so smart. Okay, so let's say 12 volts. Oh, wait, this is the one I'm doing. Oh! So let's say 50 ohms. Let's say 30 ohms. And 160 ohms. And we want to solve this circuit. So what we're going to do is just go step by step, simplifying a pair of resistors at a time, like lumping them into a single one. And eventually we'll get to the simple circuit. We'll solve that, and then we'll just work our way back step by step. So this one looks different because we've never seen one where the battery was like on the inside of the loop like this. But we'll see that as long as you think about parallel and series resistors in terms of those definitions of how they relate to the nodes, there's nothing different about anything like this. All right, so are there any in series here? Which ones? Okay, so let's do those first. So the next step, I'll just put them up there. This is 12 volts. So what's the resistance of this combined one now? Yep, in series you just add those. And this one is 160. And now, are there any in series? Nope, any in parallel? Yeah, so this is one, it's not like totally obvious. It's not obvious at all just glancing at it that these are in parallel. You have to recognize that, you know, you have to think of the definition. They share a node here, and they share a node here. And the battery shares it, but that doesn't matter with parallel resistors. So those are parallel. Where do we want to put them? It doesn't really matter. I'll just put the combined one up at the top. And so to figure out the resistance of this one, 1 over the equivalent resistance is equal to 1 over 80 plus 1 over 160. That's 2 over 160. So together is 3 over 160. So our equivalent is 160 over 3, which is 53.33, I think. Question about that? If you don't like doing fraction adding, you know, you don't have to do that. You can just plug 1 over 80 into your calculator, add it to 1 over 160, and then take 1 over whatever you get. And so Now we have the simple circuit, 53.33. This one's 12 volts. And now we can solve this. There's the positive and the negative. So at the resistor, we have 12 volts with that polarity. And so the current is this way. And now Ohm's law says 12 is equal to 53.33 times I. So I is, can someone divide that for me? I think that's 1 over E. What? Oh, 0.22, yeah. Is that 1 over E? I'm sure it is. It's not really. It doesn't have anything to do with that. Okay. All right, so anyways, the current here is 0.22 amps. So the current here is 0.22 amps. Now we know the current coming out of the battery, and that's our final answer for what's happening at the battery, because we didn't mess with that at all. Now we have to separate this out into the two parallel resistors. We know those have the same voltage. Question? Yes, at the top. Okay, so now these are parallel, and now there's something, because of the way this is drawn, it might not be immediately obvious. So we know that these are parallel, so they have the same voltage, right? They each have 12 volts. The problem is it can be tricky to figure out what's the polarity of the voltage of these two, because it's sort of in a different orientation than we're used to. Can anyone think of a way to know what the polarity? So each of these are 12 volts, but where's the positive and where's the negative? On this one, it's pretty easy. You can just sort of eyeball it. But what about this one?
Isn't that one going that way? So it will be positive be on the right side and negative on the side? Wait.
For the 80, it's going to be just like the 53. So positive is going to be on the left, negative on the right. It's a little trickier to figure out what's going on at the 160. Yeah, that's right. It's vertical. Yeah, but if you turn the other way, it would be left and right would be switched. So yeah, the way to think about it is think about what you have is, so here's what defines the polarity. The node that's connected to the positive of the battery, okay, that's the positive side. The node that's connected to the negative of the battery, that's the negative side. So, so this terminal on top is connected to the positive. So that's the plus. The other one's connected to the negative.
That's what I was saying.
Okay, maybe I misunderstood. Yes, but I mean, you can, it's always like that in the simple circuit, yeah. But you can have circuits complicated enough that, you know, you'll be working on one of these and there's no node connected to the battery.
First part of the example before we commenced it down and stuff was simple.
Right.
When I had the 3, like how would that work?
Up here?
Yeah. Like with the 30, how would that
If you're trying to figure it out here, well, then we'll see you have to go from the direction of the current, because then those are in series. You can only do like one step at a time for figuring out the directions. But anyways, I guess the bottom line is when you're breaking a combined resistor into parallel resistors, you have to think about which node is which, and that'll tell you what the polarity is. Okay. All right, so we have plus 12 there and plus 12 there. And that tells us that the current is this way and this way. And now to find the magnitude of the current, we'll use Ohm's law. 12 is equal to 80 times I 80. So 12, that is 6 2/3. Oh no, what's that? Can someone divide that for me?
12 divided by 80 is 0.15.
Okay. 0.15. And that's amps. And then the other one says 12 is equal to 160 times I 160. So the current at the 160 is, so 12 divided by 160, 0.075. Okay. So 0.075 amps, and this one is 0.15 amps. And now we can go up to the last step. Is these two in parallel or in series? Yeah. So what do we know about that? Same current. And so we know that this has a current this way of 0.15 amps. This has a current this way of 0.15 amps. And so we know the voltage polarity is this way and this way. And then Ohm's law says the voltage at the 50 is equal to 50 times 0.15, which is 7.5. Like I try all these, some are bound to be right. And then, the voltage at the 30 is equal to 30 times 0.15. So that's, what?
4.5.
Oh, I should have known that. So notice those two added up to 12. And so 7.5 up here, 4.5 here. And now it's solved.
You go through all that process just to, we can just leave it at the last one.
You probably get close to half credit if you did that. It depends how many points you want, I guess.
I got you.
Yep.
So when you're marking the voltage, you put a G with a dash behind it?
No,
Negative?
that's the negative of the polarity.
Okay.
You know, so there's the negative here on this one. That's just showing which is the positive side and which is the negative side.
Okay.
Any other questions? I had a guy in one of my mechanical engineering classes who he was like getting a C in the class, you know, and I asked him what he was planning to do after he transferred, and he's like, yeah, I don't think I'm going to do any more mechanical stuff. I mean, it's easy for me, but it just isn't challenging. I don't find it interesting. I think I'm going to do electrical engineering. I was like, maybe if you tried getting a B, it would be more challenging. You know?
For real? Did you tell him that?
No,
You should.
I should have.
Could you go up this way? Okay.
Okay. So now let me give you one to work on. So let's say this is 100 ohms. This one is 200 ohms. And this one is 75 ohms. And the battery is 24 volts. Solve this circuit. Okay, so work together, ask me questions if you get